Noise pollution is an invisible danger and it impacts millions of people on a daily basis. It cannot be seen, but it is present everywhere around us. Noise pollution is considered to be any unwanted or disturbing sound that affects the health and well-being of human and other organisms. Finding the solution from our nature, Indian researchers have now fabricated paper honeycomb and stronger polymer honeycomb structure as sound-absorbing panels that dissipate acoustic energy to low frequency ranges. Dr. B. Venkatesham from IIT Hyderabad spoke to PBNS to explain how this technology can be used in building acoustics and also as an environmental noise control solution.
One of the environmental pollution is the noise, and government of India has also taken a lot of initiatives in this way when legislation impositions are given from the noise requirement point of view. But most of my research is related to industrial noise control. So as part of this noise control strategy, we'll try to develop the quieter products and come up with the path solutions. Means like either we need to block the energy propagation, the acoustic energy propagation, and we'll try to dissipate that acoustic energy by using various materials and methods. And then finally is the receiver. So most of the times we'll try to take it as a human being as the receiver. So are we able to provide a quieter environment to the receiver was a concern. So most of our solutions are engineering solutions. Either develop the quieter product and provide the quieter dissipate that energy while the path. So whatever the innovation we try to look at it is a path solution. Okay. But ultimate objective is to provide a quieter environment to the human being.
He further explained how noise has severely affected our daily lives and how this technology can help in reducing it.
We all our rotating components, say for example, fan, motor, a garment, like you have the washing machine, mixie. Mixie is one of the major noise source in the house, right? Your mixies, right? Your ceiling fans, okay? Your domestic pumps at a home, right? Your car, your bike, every rotating component, majority of the times, that one of the outcome is noise, okay? So like this will make the sound, and we never worried about it like really that is a problematic or not, because it has a long-term impact. Okay, so you may get a headache if you continuously travel in a very noisy traffic road. Okay, so you feel more tired, right? Psychologically also you feel more tired and you will get a headache and you may be disturbed, but that is like a long-term impact. For example, think about it, industrial workplaces. The workers will work in a lot of machinery. So if you expose continuously 85 dB and above, more than 8 hours, so it will slowly damages your hearing mechanism. So then obviously what will happen, maybe around you work in that noisy environment. If you are like every 3 dB increment will make your working hours is supposed to be reduced by half. Means like so this is the way I think yes, industries are trying to make it as a effort to provide quieter environment by giving the earmuffs. Okay, but earmuffs most of the times operators may not be really interested to use it, because as a human ear is the most sensitive to know what's happening in the operations. Okay, so if you go to any mechanic, by listening the sound, he will tell there is a problem with your machine, right? That is your best natural. Yeah. So that is the way like you need to come up with, instead of giving the solution at a receiver, why can't you develop engineering products in a quieter way and provide environment quieter way? Then it is a better solution.
Nature-inspired design has attracted human interest for a very long time. And using nature as an inspiration, Dr. B. Venkatesham told his inspiration and vision behind inventing this technology.
It's like it's like experience plus the observation. I can say that's a combination of these two. Generally, in engineering products, honeycomb structures is commonly used. Okay, it's not a real. If you say honeycomb structures, it's not a novelty at any instant of time at this junction. The reason is the honeycomb structure, okay, is a very good weight to stiffness ratio. What I mean is, It has a very good stiffness with respect to its lightweight product. So the people are using extensively in a marine applications, aviation applications, right? And even package industry. For example, you see all our nowadays everything delivered at home in a nice pack. Okay, that package is also in one form of honeycomb structure, right? Those are designed from the structural point of view, right? Not from the acoustic sound absorption point of view, right? So what we thought is, why can't we look at it, come up with the solutions from the working at a lower frequencies? Why lower frequencies? What do you mean of lower frequencies? All these machines are rotating typically 3000 RPM to 6000 RPM, or all AC engines is 6000 RPM. Okay, what is the RPM? Is revolutions per minute.
Round per minute.
Okay. Yeah. So for example, 6000 revolutions per minute, we call 6000 RPM. So that you try to convert into revolutions per second. So it will become like that typically comes 100 hertz or 200 hertz. It's very low frequencies. If you want to use any traditional materials, you required a couple of centimeters thick. The material should be a couple of centimeters thick. So then we thought, okay, why can't we find a solution that should work at very low frequencies, where the traditional materials will have a limitations because of their thickness and weight. So then obviously the weight means the people always think about honeycomb structures. Then we said, why can't we look at it in mother nature? Okay, how it is responding. So what we did is, we took the natural honeybee hive. Okay, honey is not there, only hive is there, only hive. Okay, so then we tested in the absorption coefficient. The absorption coefficient is the measurement of how much energy is dissipated or how much energy is absorbed. In a layman terms, if you go to like a new home, nothing is there. Okay, all bare walls are there. Just you talk, you'll get echo. Right?
Yes, sir.
You see the echo is coming from your walls. But if you after occupying, you put a lot of furniture, even human beings are there, curtains are there, everything. So what will happen? Your sound will be absorbed by the walls. Then your echo is minimized. Right? This property is expressed in terms of the absorption, this absorption coefficient. Okay, if it's perfectly reflecting, we call absorption coefficient is 0. It's a perfectly absorbed, it's a 1. So all our engineering design should be between 0 to 1. Right? So my objective is to get a 1. And then what happened? We went to Mother Nature, as I said, we tested, we got it a hive, okay, and tested in our laboratory. And it completely surprised. The absorption coefficient is coming close to 1 between 350 to 750 hertz. 350 to 700 hertz. That is the way we are more interested in that. But the absorption coefficient is close to 1. But what is the reason? Okay, there that is the started the okay, fine, it's very nice property, but shall we explain with the existing theory? So there are good number of theories are there. We applied, nothing is working. All the theories, what is available in a traditional acoustic materials are not working. Means obviously the way the energy dissipation nature is designed is completely different. Then next question is, why 350 to 700, 750? Why can't something else? Right? That question was bothering us. Yes, still hypothesis at this moment, because I have not taken ecology department of people who are working this honeybee hives and these things. But typically bees will communicate with their wing frequencies. Those wing frequencies between this range, that is based on the size of the bee and the anatomy of the bee and region of the bee. But typically bees will communicate with their wing frequencies, and that is between 350 to 750 Hz. So now what is the hypothesis at this moment is, queen is important to survive any hive. Right? Yes. Queen is always should be there in a hive. Right? All the bees which are goes to labor bees would go and collect the honey from the different fruit. They communicate in this frequency range. In this frequency range, but the hive, the where the queen is sitting, the queen is provided a quieter environment by designing the structure.
Yes, sir.
So queen will not be disturbed by the surrounding environments. So hive is designed in this way.
He further thanked Department of Science and Technology for supporting this technology and showcased the engineered acoustic panels and discussed the features of it, as the technology is already in the 6th stage of technology readiness level.
Actually, I would like to thank the two funding agencies. One is the DST and as well as the ETEL. Okay, DST, Department of Science and Technology. They believed us, so we can make this. Okay, so you see this panel is like a 1 foot by 1 foot, means 0.3 meter by 0.3 meter. So right now we are working for a mass production machine to make it 1 meter by 1 meter panels. So these panels, if you look at it in our top ceiling, you can see just you see up, there is a tiles are there, right? Those tiles are replaced with this, right? So your most of the HVAC noise is at a low frequency noise. So these ceiling tiles, one of the immediate application, you can see the ceiling tiles, right? And wherever we are seeing applications of the honeycomb structures as a structural design, and where the sound is concerned, so you can deploy these technologies. But under constraint is we need to take other aspects of the design, like as fire safety, flame retardability, right, and material adaptability to the environment. For example, even transformer oil. So in a transformer, big transformers will make the tonal noise at a 2 times of the 100 Hz. So there you need to identify a material. Right now we have done a polypropylene. You replace this material with oil compatible materials.
Excessive noise has been found to affect our health quite seriously. So Dr. B. Venkatesham gave affordable noise reduction methods that can be used right across all the industries.
One interesting thing is one of the countries, if you look at in Asian countries, this is the only country, one of the country, I can say not only country, has a very strict legislation requirements from the noise pollution point of view. Okay, because the Environment Ministry has given a very clear legislations, okay, regarding the noise requirement, and even they have classified, okay, commercial zones, residential zones, and industrial zones. But what will happen is the implementation point of view, we need to have a little bit attention, and people are not feeling that immediate effect is not there. For example, air pollution or even water pollution, the people can see immediately. But the noise pollution never realized immediately, but it has a long-term impact.
It does. It does.
Okay. One of the example I'm trying to discussing with Vijayta now. What is that? Is the power loom operators.
Right.
Okay. That is one of the major sector in India, and also the power looms is reached to the like a very remote places. Also, people are using the power looms for, and also people are working more than 12 hours. I was giving analogies like the noise levels is goes to operate 103 dB, means like when you are near the runway, aircraft is taking off, whatever sound you are getting, 3 level of approach to be followed. One is try to provide a hearing protection devices to the operators. Second one is developing the quieter technologies, because providing the ear protection device is not a comfort for the long-term operations. Okay. So obviously we need a complete holistic approach. Holistic approach means you assess the person, what is the impairment he has, hearing impairment he has, provide HPDs, means like hearing protection devices, but that is not the permanent solution. The permanent solution is providing the quieter technologies. Okay, when you're so for that actually there is a 20 years back my professor told me India is trying to implement the noise. What I mean is, for example, we have a power energy star ratings are there. 5-star product means like a
exactly.
Why can't we have a star rating or color coding on all products which are coming in India from the noise point of view? Okay, so what it means is, for example, this is the parallel to the energy star rating. You should have the noise rating also. Yellow, green, and red. So the same product, mixie is one of the example. A mixie you will get it for 2,000 rupees at home, kitchen home, right? You will get it for 7,000 rupees.
Absolutely,
right?
absolutely.
Right. So now you keep it a branded branding. Say that is a green means it's acoustically meeting all the requirements. So everybody knows it. Okay, if you buy this, at least in my kitchen is quieter kitchen.
So that's it for now in an exclusive conversation with Dr. B. Venkatesham. Stay tuned with PBNS for all the latest updates. Thank you.